What's up, everybody? Mr. Lane's here to talk to you all about the chart of the codons. This is on first appearance, it looks very overwhelming and kind of confusing, but it is super easy to use, and I'm going to teach you how to use it. If you want to watch just the first part of this video, that's great. I'm going to talk just about the chart of the codons and how to use it. The second part of this video, I'm going to go into the assessment for this unit, which is how to make your secret message and turn it back into DNA. So I'm going to talk a little more than what you might need right off the bat. So if you want to watch just the first part about how to use the codons and then watch the rest later, that's totally great. So here we go. The chart of the codons. First, before I talk about this big circle-looking thing of awesomeness right in front of me, I'm going to refresh your memory. A codon. A codon is a set of 3 nucleotides. Those 3 nucleotides are originally in DNA. They are then transcribed into mRNA. Those 3 nucleotides, for example, A, U, and G, are going to represent one codon. So those 3 nucleotides equals 1 codon. That 1 codon then translates into 1 amino acid. We use this chart that is before us to translate from the codon to the amino acid. So we know, like, hey, we got this mRNA strand. What amino acids is it? This is how we figure it out. So the way you're going to start is, let's look at the circle thing here together. In the center, we have A, U, C, and G. So this is RNA because we see U. Because we remember, we pity the fool who forgets about uracil. We don't have any T's in RNAs. RNA is so much better than thymine. Anyway, A, U, C, and G. That's the first letter of your codon. So if we have our triplet, we're going to start with A, and then we're going to go to U, and then we're going to go to G. All right? So let's start here with A. So what that does is that puts us in the lower left-hand quadrant. And then we're going to say, okay, what's our second letter then? We're going to look at this options here. We're going to see U. Cool. So we're going to go A, U, and then we're going to go, okay, now what are our options in that kind of that third ring? And we're going to say G. We know that AUG stands or is translated to methionine. Methionine. So that is what all the proteins start with, because that is what we call the start codon. So that's where the small subunit of the ribosome latches on and says, boom, I got me an AUG, large subunit latches on, and then translation occurs. So every one of these codons starts with AUG. So let's try another one. Let's say, I don't know, throw one out there. What's that? Okay, yeah, that's a great one. UCG. Let's try that one. Let's try that one. That's a great idea. U, we're going to start up here, and then we're going to go to C, and then we're like, wait, whoa. It's UCANG, all of them, bro. So UCG gives us serine. But we also know that UCC will give us serine. We know that UCU will give us serine, and you guessed it, UCA will give us serine. So what this is telling us is that there is more than one codon for different amino acids. In fact, if you look at some of them, they're all over the place. We have leucine here that has CU and then whatever, but we also have these leucines up here, which is UUA. Okay, so there are multiple different codons that can code for the same amino acid. The last thing I want to bring to your attention is that we have stop codons. Think of translation as you are sending this message. So it has a message. You need to know when to stop. Just like a sentence, if you're writing it, you need to have punctuation so you know when to stop reading. There are 3 stop codons. We have U, G, A. We have U, A, and UAG. So there are 3 stop codons. So when you're writing your message, don't forget the stop codon. Simple enough? Cool. That will conclude the first half of this video. The second half, I'm going to go back up to the top part of this document, which is making the code, which you'll see in the links. And I'm going to talk a little bit about how to make your secret message. Cool? So stop watching now if you only want to chart the codons. All right, well, thanks to the rest of you for joining us. Here we go. We're going to go all the way back up to the top here. Sorry for the scrolling. So when you are writing your secret code, this is the document that you're going to be using. We have created a list of words that you can use that transcribe or that translate into different amino acids. So first, look at the words and create the message that you want to create. All right. The only stipulation is that your word, your phrase, your secret code has to start with the letter A. So like A blank. And that is because we know methionine is AUG. So I would write down the code. Let's say I'm going to make a word. I'm just going to go with a big cheeseburger. That's what I'm going to use for the purpose of this course or for this video. So if I want my message to be a big cheeseburger, I'm actually going to have 4 codons. I'm going to have the start codon A, I have to have the codon for big, and then I'm going to have the codon for cheeseburger. I'm also going to have a stop codon. So don't forget about that stop codon. So even though I only have 3 words, I got to have a stop codon. So the first thing I'm going to do is I'm going to write down my message. I'm going to write a big cheeseburger. And to do that, I'm going to use this next chart. And then I'm going to type in big, and then I'm going to go cheeseburger. And then I'm going to type in a stop codon. Okay. So big, I know that I have to go back up here and I'm going to look at big. Oh, that's cysteine. Cool. That's some nice sulfur in that one. And I'm going to look at cheeseburger, and that I know that one is tyrosine. Okay. And then I'm going to pick a stop codon. We'll do that in a moment. So now I know that my amino acids are methionine, cysteine, and tyrosine. I'm now going to go back down to the chart of the codons, okay? And I'm going to look at cysteine. I already have AUG with methionine, that was good. So I'm going to look at cysteine. So now I'm actually going to start on the outside of the ring, and I'm going to find cysteine, bam, there's cysteine. And I need to look at what are the codons for cysteine. So in order to get to here, I have to start with UGU or UGC. So I'm going to pick UGC. So I'm going to write that right here, UGC. And then I'm going to look up tyrosine. I know tyrosine has some too. Let's check that out. Here's tyrosine right up here. And I'm going to go UAU. I like UAU. Cool. UAU. And then the last thing I need to do is put in my stop codon. No amino acid on here, but we need a codon for my stop codon. I'm going to pick UGA. Cool. UGA. So there is my RNA sequence. I'm going to start with AUG. I'm going to go UGC, UAU, UGA. Now I have to kind of reverse transcribe that into DNA. So what goes with a U? Well, an A goes with a U. What goes with a G? Well, a C. What goes with that? Well, a G. So now I'm making my DNA code. So I'm going to go A, T, A. I'm going to go A, C, T. So then this is my DNA code. This is the product that I'm going to use. It's going to be my DNA code. The final code that I'm going to put all this together is going to be TAC, ACG, ATA, ACT. That code, when it's transcribed and then translated, will code for the message, a big cheeseburger. So that's what we got to do. What you're going to do for the rest of your assessment is you're going to be given not a random, but you're going to be given a secret message in DNA, and you're going to have to explain how you decoded that message, and then you're going to mutate it and see how that mutation affects the message that you were given. So if you have questions, as always, please reach out. I hope this was informative. I hope this was useful. We'll talk to you soon. Have a good one.